You'll notice that I drew in these marks. That was added information. I think it was supposed to be written here, but it's actually unnecessary to even write because there's a theorem in geometry that we learned about. We didn't learn it by name necessarily, but if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. It's called the perpendicular bisector theorem. So if you wanted to look that up, then you would know that if this diameter is perpendicular to this chord, we automatically know that it also bisects that chord and the intercepted arc. So if the diameter, AB is the diameter, AB is 11, okay, so diameter is 11, which means radius is 5.5. Calculate the lengths of CE and PE. Okay, so I'm going to draw a radius from P to C so that PE and CE are now a triangle, CPE. And they're a right triangle, which is awesome because then we can use some Sohcahtoa magic. Okay, the measure of arc CBD is 110 degrees. So this out here is 110 degrees, which means this central angle, is equal to the measure of its intercepted arc. So this is also 110, but really focusing on the triangle that we want to focus on, what is half of 110? Since this triangle involves half of this angle, that would be 55. So this angle is 55. The radius of the circle, remember radii can be anywhere from the center to the edge. The radius of the circle is 5.5. Now we have a right triangle with an angle and a hypotenuse. We can use Sohcahtoa to find our adjacent side and our opposite side. So sine of 55 is equal to CE over hypotenuse, which is 5.5. So CE is equal to times both sides by 5.5. And we have 5.5 times sine of 55 is 4.5. That was CE. 4.5, they didn't give me any units, so I just put U for units in general. And then cosine. Set it up the same way. Cosine of 55 is equal to PE, our adjacent side, over 5.5. PE, we need to times both sides by 5.5. And we get 5.5 cosine 55 is 3.2. 3.2 units. Use the diagram at right to answer the following. Remember how we can make two intersecting chords of a circle into triangles. DA is an arc. We don't know its measure. We don't need to know its measure, but any inscribed angle that intercepts arc DA will have the same measure of any other inscribed angle that also intercepts DA. So this angle intercepts DA, and this angle intercepts DA. Therefore, the orange angles are congruent. Same with the angles that intercept arc BC. This angle and this angle. These are congruent. Plus you have your vertical angles in here. Anyways, we've already shown that they're similar by angle-angle similarity. And now we can use proportions to solve for our missing parts. I will color in these last angles. Makes it easy for me to see where I'm going to put my proportions. I like to start with the big side first, so I will do the side between the orange and blue angle over the side between the blue and orange angle. So 20 over 2t is equal to, now I'm starting with this exact same triangle, the bigger triangle, and I'm going to go 10, the side between the blue and purple angle, over t, which is the side between the blue and purple angle. So 10 over t. And I will cross multiply, even though you could potentially reduce as well. But I think it's easier to cross multiply. So 20t is equal to 2t times 10. 20t equals 20t. Get your t's by themselves. Together. So 20t minus 20t, 0 equals 0. When your variable reduces out to 0 and you have a true statement, 0 equals 0, then your answer to that equation is infinitely many solutions. Infinitely many solutions. This isn't the same as infinity. Infinity is a direction or a concept. Infinitely many means an infinite amount, I guess. That's pretty obvious. Okay, if AB is a diameter, then find the area of the circle. Okay, AB is t plus 20. Okay, t plus 20. That's my diameter. Okay, the area of the circle, area of a circle is pi r squared. We're not going to be able to get a number out. We have to leave it in terms of t. What's the radius? If diameter is t plus 20, the radius is t plus 20 over 2. Now we plug this in for r. So the area should be pi times t plus 20 over 2 quantity squared. And that is my area. All right. In a certain small town, 65% of the households subscribe to the daily paper, 37 subscribe to the weekly paper, and 25 subscribe to both papers. Make a two-way table, including totals, row total and column total, to represent this data. Okay, so we're taking a big 180 and going to probability instead of, as opposed to circles, which we've been doing. So I'm going to make a two-way table. Total. I'm going to label, okay, 65% of households subscribe to the daily paper. Okay, so daily paper is going to be my event A. That's just because they wrote it first. Either way, you'll still get the same results. And then I'm going to write weekly paper as event B. So what you should have for a two-way table would be A, not A, B, not B. So daily, not daily, weekly, not weekly. And then we're going to fill in the information that we know. So 65% do the daily paper. So that would be total, daily total. 37 subscribe to local. So weekly total is 37. 25 subscribe to both, weekly/daily. And what's total? Well, since we're working with percentages, 100%. So let's fill those in. We have 25 plus what is 37? That's going to be 12. 25 plus 30 is 65. That's 55. Sorry. Plus 40. $37 plus, as we can see, my mental math is not so strong right now, so let's just use a calculator to ensure that we're getting the correct amounts. 40 plus 23, 12 plus 23, 65 plus 35 is 100. Good. Okay, so we're done with our two-way table. If a household is selected at random, what is the probability that it subscribes to at least one of the two papers? Shade these areas in your table. Okay. If you subscribe to at least one of the papers, you could either be in this group, where you subscribe to both. You could subscribe to the weekly, but not the daily. You could subscribe to the daily, but not the weekly. Add those percentages up. $77. And now we're going to do the last problem. It still refers to the two-way table, so we might be flipping back and forth. Charlie's neighbor subscribes to at least one paper. What is the probability that he receives the daily paper? If you recall, conditional probability goes like this. The probability of A given B, this is actually the symbol for it, is equal to the probability of A and B, also known as intersection B, over the probability of B. So going off of this formula, I can write, okay, so Charlie's neighbor subscribes to at least one paper. That's what we know. What is the probability he receives the daily? So the probability he receives the daily paper, given that you know he subscribes to at least one. So at least one subscription. So this would be the probability of daily and at least one subscription happening. And if you see, that's going off of the orange circles that we had before. So the only intersection of the orange circles and the daily would be 25% and 40%, which is 65%. So for intersection, for A intersection B, that would be 65% over the probability of B. B in this case is at least one subscription. So what was the probability that they had at least one subscription? You did that in part B, and that was 77. So 77%. When you put these into the calculator, you can write them as decimals and then put them back into percent. So 0.65 divided by 0.77 is 0.84 as a percent. That's 84%. That's it for this page.